yeah.
All right, Liam. So we hear there's a Parker Solar Probe launching this weekend.
Yes.
What does that mean?
So the Parker Solar Probe is basically a spacecraft, an unmanned spacecraft with a bunch of sensors on it, flying on Saturday morning, actually at 3 o'clock in the morning, flying towards the sun to really analyze the solar wind coming from the sun.
Has this been done before?
Actually, it's been done for quite some time, but not in this scale. It's usually what we did was because the closer you get to the sun, the hotter it gets. So usually what the probes before it did was to keep at a safe distance and really look at it, analyze it. But this time we really want to literally dive into the solar corona and get measurements from in there.
Okay. What did you do on this project, and why are we listening to you today?
Well, I guess we're listening to me today because I'm the only one here at RadioBro who knows anything about it. I helped verify one of the sensors on the solar probe. Yes, on the Parker Solar Probe. It's the Solar Probe cup. It's basically a Faraday cup that measures the incoming electrons and protons and heavy ions and their energy, their velocity, and their angle at which they're actually getting into the probe.
Is the sensor that you worked on, is it going to be used while it's outside the corona on the way in, or as it passes through the corona?
It's actually one of the few sensors that peeks out of the thermal heat shield. The thermal heat shield is what actually keeps the spacecraft safe. It's a carbon composite literally shield that is 4.5 inches thick, and it's gonna just burn up in I think it's about 24 dives. So it will be burning away, and the solar probe cup will actually peek out there and look directly into the sun.
Okay. Maybe someone can comment with a link to that heat shield. I think NASA posted something recently on it, kind of showing people how it works. That was really interesting. But to have something sticking out through the heat shield sounds like kind of a rough environment.
Oh yes, definitely it is. It gets up to about 2,500 degrees Fahrenheit.
Oh wow.
Out there, so that really gets hot. And if you want to get a scale of it, we are about 90 million miles away from the sun, and the solar probe, the Parker Solar Probe, will dive into up to 4 million miles close to the sun's surface.
So what's those numbers again? How much closer are we getting?
Instead of 90 million miles, it's 4 million miles.
Okay, so we're going up way close.
Yes, way close. It's going to be really hot, but because of that, we will, in the really hot zone, will only be for about 11 days, and after that, we'll shoot about 77 days out just to cool off.
Oh wow, okay.
Just to cool off, just then to go back and dive in again.
So how long has this probe been in development?
I think the critical design review was done in 2015. So
okay.
It's actually for
it's a
spacecraft. Yes, it is a fast program. That's probably also because of it is complex, as every spacecraft is, but it's not very big in size. This whole probe has a height of 3 meters.
Oh wow! Okay,
that's not big. The heat shield has a diameter of about 2.5 meters, so it's really not big, and it weighs about 700 kilograms, which is less than I think a Honda Fit. So
okay,
that's small.
So if I was watching the news recently from NASA, they said it would take like 6 or 7 years before it's actually going to go into the sun's corona. Is that about right?
It's going to burn up in about 6 to 7 years in the sun's corona. The first dive will already still be this year. We have in the whole orbits, we're gonna do some 7 flybys at Venus to do gravity assist to get into the right orbits, and the first gravity assist will be at the start of October, and the first time that we are really close to the sun is gonna be at the start of November. So that's only in 3 months. That's why we have a very small satellite put on a very big rocket. So it's going to be very unique flight. It's in the middle of the morning, so at night it'll be pitch dark until those boosters go off, and we'll probably won't be seeing too much of it for too long while it's flying up.
And is it just, you just point at the sun and go straight in, or what's the trajectory look like for the mission?
The trajectory, it kind of comes around a little bit in a circle. First of all, we want to do the flyby by Venus. That's why we have certain launch windows. But at the same time, if you just straight point at the sun, you literally straight go into the sun, which you don't want to do. So that's why you need to do that. In addition to this, there's a lot of energy involved to getting towards the sun. You wouldn't think that, because you would think, well, it's gravity, it'll just pull it towards you.
Sure.
But because we are on Earth, everything is flying with Earth's velocity around the sun.
Okay.
And you would have to negate all that velocity to literally just fall down. So it's not that easy to fall.
So we're going too fast already.
We're already going too fast, yes.
Well, that sounds like it's one of the biggest rockets that's currently in use, if not the heaviest launch capability that we're using, and relatively new rocket. What else do you think is interesting about this mission?
The interesting thing about this mission is the impact it will have, because it's not just being daring and getting close to the sun. The solar environment and the solar wind in particular is something that we really haven't understood very much. The thing is, if you look at the sun, we've been doing that for all of mankind's life. So we've seen the sun so long, but up until the last probably 50 years, we haven't really understood the mechanics about it, and we didn't know about the solar wind. The person who gave the name to the Parker Solar Probe, I think it's Eugene Parker. I'm not sure of the first name, but it's Parker. He did his theories.
We'll throw like a Wikipedia link or something in the comments.
Yes, that would be great help for me, thanks.
Yeah.
It's in 1950 he came up with the theory behind how the solar wind gets created and is pushed out with the magnetic fields and all these things. And the interesting thing is that the temperature of the sun is about 6,000 Kelvin, which is already pretty hot. But if we go higher in the atmosphere of the sun, it even gets hotter.
Oh.
And that's that's unusual.
Yeah, that would be strange.
Yes, so we don't know why this is. And we assume that is also the cause why the solar wind actually accelerates what is being pulled out of the sun. Where if you're like, well, it's gravity, it should pull it back, it slow it down. No, it gets accelerated, and we don't know why.
Huh.
And
that's very interesting.
This is one of the reasons why we do it.
All right, so I suppose when I was working at NASA, my research was how to use the solar wind to shove ourselves through the rest of the solar system and out into the universe.
Yeah.
And I never really researched going towards the sun, because that's, I guess, the more aggressive area to go. So this is really fascinating. What has the development life cycle been for the instruments? What type of data have we never seen before that we're going to look at that is going to be unique?
It's really about the structure of the magnetic fields and the velocities of the solar wind and the composition of the solar wind at that point. Because we're out here, we basically it's like getting the edge of a tornado or of a typhoon or anything like that, and just seeing the typhoon from afar. You really don't understand it until you get into the nitty-gritty.
Okay.
And you look into it. And
so I guess with in recent years we had things like the entry, descent, and landing on Mars. Are we going to see something dramatic that we all need to huddle around the TV one night about, or is this going to be something that's longer?
As the whole mission is going to be 7 years, we'll have, and it's about 24 orbits, we will have the opportunity to get more and more pictures. One of the sensor systems on it is a camera, and it'll take, in addition to all the measurements that we have, it'll take pictures of the events it flies through.
Okay.
So we will have it's probably a little bit like the Star Trek starting scene where you see the Star Trek Voyager flying through these magnetic field lines. maybe not as close as that, but it'll be pretty close.
Okay.
So we will have pictures of the sun like never before.
Well, we've had Hubble up since when I was born. I guess the real thing for me is like, why haven't we used existing optics, or have we? What's different about going through the corona?
It's really taking measurements at the spot. It's
Okay.
a little bit like comparing if you have a car and you see the car driving around and it's fast and you don't understand why it is fast. You want to look at the motor.
Okay.
And that is really what we're doing. It's going into the sun, taking measurements directly at the spot, because we cannot do that with just visual. We can look at it all we want, but we already have all that data that we can gather from looking at it. We need to go in there and measure, for instance, the solar probe cup will measure the velocity distribution functions of the solar particles in the solar wind. So it'll tell us directly at what angle the velocity is facing, where is it pointing at, how is it actually throwing out there. And this is that, and including, we are hoping that we're going to fly over a sunspot or something and see how does a sunspot change the velocity distribution in the solar wind.
I've known some other people in Huntsville. Obviously, we have a lot of space weather physicists and some people that I've known for a long time that have worked the solar models for especially our governments and the scientific community. How is this going to impact their models and their ability to simulate and observe the sun's health?
It really is gonna verify a lot of stuff that they did. So they built up all those theories, built up all those models, but you can only really model, or you can only verify the model by checking it out. And it's comparing it to the data that we have. We know how it's supposed to look. Now we just have to see, does it actually look that way? And then we can go ahead and start maybe predicting weather, predicting the solar weather. Because solar weather, we've never really had a big problem because we live on Earth, we have our magnetic field. It saves us from those winds usually. The only time when we actually see it is through the auroras that we can sometimes in the northern hemisphere actually see and experience. But if there's a really big event like a coronal mass ejection where a lot of that stuff is just thrown into our magnetic field, it'll come through and you'll have complete grids that go out. That already happened in Canada, I think in 1978. And those things are only getting worse because we are now building satellites. We have the space station.
Digital infrastructure.
Yes, exactly.
Yeah.
Those are far more impacted by these events.
So here's a chip here. You know, we've got a lot of automotive components. What's the difference between the chips that are on here and the chips that are in the solar probe?
The solar probe's chips, they will be they'll be hit by a lot of particles, and particles so fast and small that they'll just hit right through shields, and they will hit into usually the small components and do bit flips and do a lot of, and they can actually destroy a chip. So they will have to be saved against it.
So how did the design team develop the electronics, I suppose, for that? With such an aggressive flight path going straight through that solar wind, what do they do?
To be fair, I don't know the specifics.
That sounds like it's been pretty hard.
Oh yeah, definitely. I'm pretty sure the heat shield will help a bit, but at the same time, we're so close at the sun that we see the sun from the front, but we might as well get hit from the side too. So that is not just the only thing. There will be a lot of shielding and a lot of components that are really built for these environments.
Sure. Okay. Do we have any questions from Facebook?
Yes. Patrick says, can you go over the different instruments on the spacecraft again?
Okay, so there's, I think, 4 main suites, instrument suites on the spacecraft. There's the one that is, can I just have my notes? I came prepared. So we have the field experiment, which focuses on the magnetic field lines and the magnetic field waves, the plasma density and electron temperature.
Okay.
So it does a lot of the magnetic fields. Then we have the integrated science investigation of the sun, which is observing a lot of the electrons and heavy ions and protons, looking at their energy level and correlating them with the coronal structure while we are flying through it.
Yes.
Then in addition to that, we have the wide field imager for the solar probe, hopefully getting a lot of nice pictures and also having visual effects of maybe coronal mass ejections flying at us.
That could be
Hopefully
dramatic.
You can't plan those things, they just happen. You hope you can just press the trigger. And then the solar wind electrons, alphas and protons investigation, which is the sweep investigation which the solar probe cup is part of. And it looks at the most abundant particles, the electrons, alphas and protons.
If I remember my physics textbook, the solar life cycle is about 11 years.
Yes.
So that's our magnetic switching, and it's the magnetic spin up and spin back. Where are we in that life cycle? I guess we'll observe most of it through the 7-year life of this mission.
Yes. I'm pretty sure we just passed a high.
Okay.
I think it was, we might be just in the high. It's very close, definitely. Okay. Or is it a low?
I'm not
sure, actually.
We'll Google that, and we'll throw that into the comments feed.
Exactly.
Because I figured that if we're going to launch, we'd launch at maybe a minimum, and then we would watch it escalate over the years.
Yes.
I would hope. I'm getting confirmation. Yes, it sounds like we're going to be entering it in a low. So we must have just finished the high.
Yeah.
We're going into low.
Makes a lot of sense for the launch window. Yes.
So is this a polar launch, equatorial? Like, what's their way away from Earth? How do we get into Venus?
I'm pretty sure it's gonna be what's it called? Equatorial launch.
Okay.
Just to get more speed in, and we don't need a polar launch.
Sure.
It's really not needed, and we might as well just fly out.
Okay. What other questions are out there? Okay. Cool. Let's see. Do you know how do we learn more about this this probe?
Well, you can first of all go to the website of the Smithsonian Museum. They have, because they are one of the great contributors to this probe, and at the same time at Marshall JPL on their website, you can see it there. But Johns Hopkins.
Yep. And I guess we'll throw the link to the research, the applied physics lab at Johns Hopkins on there, which I think developed the probe.
Yes.
The NASA link, which was I think the mission was operated through Goddard, and of course where do we launch or watch all the live launches?
At NASA TV.
NASA TV and Spaceflight Now for some really good feedback for that.
Yeah.
Is there a long launch window? What's our launch window this time?
This time it's I think it's about 7 hours or something.
So
6 to 7 hours.
Are you gonna go light the match under the rocket, or?
I'm not gonna light the match under the rocket, but I'm gonna get as close as I can, and gonna stay up late, maybe get a few hours of sleep before, and because, as you said, there's a launch window, so they don't have to launch it at 3:30 in the morning, but hopefully they do, so I can get to bed. And,
I've seen. Have you been to Canaveral for a launch before?
No.
First launch.
First launch.
I was there for the last night shuttle launch, I think, which was STS-131, and I was there for STS-135, the last shuttle launch, which is a daytime flight. And I was down there. We went up to Wallops Island to watch the Chartersat-1, the university satellite, which is before RadioBro, almost 5 years ago.
Wow.
So it was November of 2013. So it's almost 5 years ago now. So love launching. We're here to launch stuff to space. And I suppose this probe is a little bit bigger than the CubeSats we normally launch, or the Pocket Cubes, like what Tom in the UK is building, and a few of the other academic team and commercial teams are making. And you said 10 meters tall?
No, 3.
I'm sorry, 3 meters, so approximately
so it's about 10 feet. Yes.
10 feet or so tall.
Yeah.
Cool.
Patrick has another question.
Hey Patrick, what's your question?
He says, does RadioBro have any products that could be used on a spacecraft like that?
What do you think?
I'm pretty sure we can.
Yeah, we've got the design team, so we're ready to go. So
Yes.
All right, cool. Well, thanks for joining today. Thanks for joining on Facebook, and we'll watch the launch this weekend.
Exactly.
All right.